Okay, we're going to take a look at unit number 7 today. So starting with integral exponents and how exponents work, some exponent rules, how to deal with exponents. Okay, so a good starting point here is we have this idea about which is a better deal. If you got to receive $1,000,000 a month, once a month, for the year or whatever, or it would be better to get 1 cent the first day, 2 cents the second day, 4 cents the third, 8 the fourth, 16 the second next, and so on, which is a better deal. Okay, because this is an example of an exponential function. An exponential function is something that grows by the same amount over a period of time. In this case, we're doubling, right? We go from 1 cent to 2 cents to 4 cents to 8 to 16 to 32 to 64 to 128 and so on and so on and so on. Okay, or if you think about it, we're taking us 1 cent and we're timesing it by 2 for every day of the month. Double, 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 as many times as we need to. Or, if there's 30 days in a month, 1 times 2 to the power of 30, an exponent. That's a simpler version of writing that thing. If I do that, 1 times 2 to the 30, I end up with a rather large number, 1,073,741,824. Now this is cents, remember, so in dollars, move that decimal spot over 2 to right there, I still end up with 1, 2, 3, and 1, 2, 3, over $1,000,000, even though it's being paid in pennies at the beginning. Okay, so it'd be better to take this idea of the doubling time. But the objective here isn't necessarily the dollar value. It's the fact that I want to start working with some exponents. Exponents are faster ways of writing mathematical expressions. This particular ones involve multiplying or dividing. That's the one we just did here, right? Who wants to write out 2 times 2 times 2 30 times? When I know that I can write out 2 to the power of 30, it's much faster. So there's some rules we need to remember from grade 11, exponent rules. Okay, 4 of them we're going to review, and then we're going to add some new ones in for this course. Okay, rule number 1, if you multiply your bases, you need to add your exponents. So if I have a to the m times a to the n, I get a to the m plus n. Numerically, that's like 2 to the 3 times 2 to the 5 would give me 2 to the 8. I add my exponents. Okay, the opposite, if I divide my bases, I subtract my exponents. So if I had 3 to the 9 divided by 3 to the 4, I'd end up with 3 to the 5. Okay. A power of a power, I'm going to multiply my exponents. That would be something like a to the m to the n. Or numerically, 4 to the 2 to the power of 5, let's say. I'd end up with 4 to the power of 10. I'd multiply my exponents. Okay, and the 0 exponent always equals 1. Okay, it doesn't matter if it's a letter, a number, whatever it is, a big, long, complicated expression. If I get a power of 0, it always comes out to 1. Okay, these are rules we've seen before. We're just going to work with them a little bit. So let's try some things. I want to simplify some expressions. Simplify means make it easier, prettier, nicer, a smaller version. All right, so rules. I got bases that are multiplying. That means I'm going to add my exponents. I got power of 11. I got a power to a power. And I'm going to multiply my exponents. Okay, so 3 to the power of 28. This one I've got multiple parts. So on top, I can add my exponents. I'll get 9 to the 9 over 9 to the 3. And then, because it's dividing, I can now subtract my exponents. 9 to the 6. Okay, I can only do this if my bases are the same, right? That's kind of one of our key rules. Okay, take a look at the next one, letter D. X to the 4 times y to the squared, all to the power of 4. This is the power of power. Now it's got to be applied on both parts, because it needs to apply to everything inside that bracket. So I'll end up with x to the power of, well, remember power multiplying, so x to the 16 and y to the 8. Apply it to both parts and make sure you're multiplying. Okay, E is the same idea. I got to apply it to everything inside the brackets, and I'm multiplying. So I get a to the 6 on top, and on the bottom, it doesn't show it, but we know there's a 1 on that b, so I get b to the 3 on bottom. Okay, apply it to everything, and you're multiplying. All right, letter F, a power of a power again. When we said powers of powers, we're supposed to multiply. So what does that actually look like? Well, my base is x, and I need to multiply the 2 times the 2 plus n. So I'll get an answer like x to the power of 4 plus 2n, because I'm using my distributive property, expanding my brackets. Okay. If I try the next one, I got bases that are multiplying, or I have bases that are multiplying, I'm supposed to add my exponents. So I need to take p as my base to the power of x plus y plus x. Add all the exponents together, right? A better way of writing that might be 2x plus y. And if you look at h is a tricky one. It doesn't look so tricky, but h is a tricky one because I see a plus sign. But here's a big idea here. If you see plus signs, plus or minus, exponent rules don't work. We go to bed mess. Okay, as soon as I see that plus sign right there, oh, bed mess. I don't do exponent rules anymore. How does bed mess work? I got to do the stuff inside the brackets first. So I need to do 10 plus 10 squared, which is 100, before I even start thinking about the exponent on the outside. So I got 110 squared and 110 squared, which in our calculators, and we end up with 12,100. Okay, there are no exponent rules. No exponent rules at all when you see pluses or minuses, okay? Notice all the rest, all were multiplying, dividings, or powers of powers. Okay, okay, new rule for today. We're going to learn something new, negative exponents. Okay? Negative exponents can come up when we simplify things. For instance, this first one here, I end up with 2 to the 4. I'm supposed to subtract the 2 to the 7, because that's what my rule says. So I end up with 2 to the negative 3, which is great, but we don't like working with negative exponents. Negative exponents are messy things to work with, so we need to fix this. To fix this, I'm going to go back to my idea. What is 2 to the 4? 2 to the 4 actually means 2 times 2 times 2 times 2. 4 of them, right? And on the bottom, I need to have 7 of them. 3, 4, 5, 6, 7. One of the nice things about fractions, because this really is a fraction, it's got a line down the middle, is if I have the same thing on the top and the same thing on the bottom, and they're multiplying, I can cancel them. I can cancel this 2 with this 2. I can cancel this one and this one, this one and this one, this one and this one, and I'm left with an expression that's 1 over 2 times 2 times 2, or in other words, 1 over 2 to the 3. Okay? So mathematically what I've just shown is, if I end up with a negative exponent, it's the same thing as the reciprocal. And by that I mean I flip it over. 2 over 1 becomes 1 over 2, and my exponent becomes a positive. Okay? There's a little rule for you, right? It's on your page, but so we have it on the same page together. Okay? Move that down. Yeah, our rule is, oops, if I have a negative exponent, it's equal to the reciprocal to the positive exponent. So x to the negative a becomes 1 over x to the a. And the reason why is there's a 1 underneath here, right? We flip that over, it becomes 1 over x. So if we try example b up here, let's simplify this. 3 to the 2 divided by 3 to the 5 comes out to 3 to the negative 3. I subtract my exponents. But I don't like having negative signs. So what I do is I take my 3 over 1, and I flip it over, and I write my exponent as a positive. Okay? So then we have positive exponents all over again. And our objective today is going to be making exponents that are positive. So let's try some more. And we're going to use our exponent rules. We're also going to simplify. I want to rewrite each of these with a positive exponent. So part A, it's as simple as it can get, but it's got a negative exponent. So I'm going to flip it over. 1 over 6 to the positive exponent. If I try B, I want to simplify this first. What should I do when I have exponents that are, bases that are the same? I should take these things and add them together, right? I'm multiplying my bases. So negative 5 plus negative 2 is negative 7. There's my exponent. Oh, but I don't like negative exponents. Gotta fix that. Let's flip it over. Oops. Didn't mean to do that, sorry. If I flip that over, I end up with 1 over 3 to the positive 7. Okay? My base isn't changing signs, it's just changing the position of things. It's the exponent that's changing signs. Oh, yeah, it's a good C. Oh, C has a negative on the bottom. What should I do with that? Well, we said if you have negatives, you should flip them over. So instead of 1 over 3, I end up with 3 over 1, and my exponent becomes a positive. Now, we don't usually show the 1 on the bottom, so this is the same thing as saying 3 squared. Much easier, right? Sort of a little trick for you here, okay? If you want to think of this. A negative on the bottom becomes a positive on top. Negative on bottom becomes a positive on top. Or vice versa. Go back to the first question, right? A negative on top, or a positive, sorry, a negative exponent on top becomes a positive on the bottom. Okay? And be careful, I'm talking about the exponents here, right? Not the bases themselves. That's kind of a key idea when I look at D here. Hey, I see a negative exponent on the bottom. So I know I should bring that to the top. What's the base? The base is negative 5. So I need to keep it in brackets to say that's my entire base, and my bases never change, but my exponent becomes a positive. It was a negative on the bottom, so it became a positive on top. And we're talking about the exponents here, not the bases, okay? Okay. Fractions. We can have fractions. Now, all the ones we did so far had the number 1, which I suppose is a fraction, but it's not a very complicated fraction. If we have fractions that involve more than the number 1, we can raise those to negative exponents too. And we do that by writing the reciprocal to a positive exponent. Reciprocal means write it upside down, like we've been flipping things over. So if I get 2 over 5 to the negative 2, that's like saying 2 to the negative 2 and 5 to the negative 2, right? Apply it to both. Oh, I see a negative on the top. I should bring it to the bottom. I see a negative on the bottom. I should bring it to the top. So what I could have done right from the beginning was to take my fraction and flip the whole fraction, right? If I look at this, doesn't that what's actually happening? I'm taking my fraction, flipping it over, and making my exponent positive. Okay? So I can go through the big process if I wanted to, but it's easier just to skip to the end. If I flip the fraction, my exponent becomes a positive. Hey, one big idea here. Be careful which things have negative signs on them, because some things have positives, some things have negatives. All I really care about are the negative exponents. But look at the expression right here. I want to simplify this. Okay, the things with the negative exponents are ones that need to be fixed. The b has a positive exponent. It's just fine the way it is. Leave it there. The things with the negative exponents are ones that need to be fixed. So if I have a negative on the top, it should go to the bottom. Change exponent to a positive. The negative on the bottom, exponent, needs to go to the top. The exponent becomes the opposite, positive. And that is the parts that need to be fixed. The b was fine just the way it was. Okay, so be a little careful which ones need to be fixed and which ones don't. Okay, okay, let's fix these ones. Rewrite each with a positive exponent. I see a fraction with a negative, so I flip the fraction and make my exponent positive. And I look at the b. I look at the things that are, what's negative? Well, the x is fine. It's a positive exponent. The y is a problem. It should go to the top. So it's going to join the y on the top. And you can imagine there's a little 1 down here, but you don't have to put the 1 there. It doesn't mean anything. And look at c. Oh, a negative exponent. It's got to go to the bottom. The b is a negative. It's got to go to the top. Okay, so we're flipping things over, but we're being smarter about it. Negative on the top becomes a positive on the bottom, and vice versa. Okay, I'm going to do the last couple examples on the next video.